What is the Internet of Things?
Okay, so the Internet of Things refers to connectivity of everything. And what we mean by everything is items that would not ordinarily be connected, whether it's pot plants, industrial equipment, animals, having connectivity to some kind of back-end cloud infrastructure, not just to be geeky, but to give us insights into what's going on and how we can best use that information.
Okay, so let's break it down to more practical terms. So, could a city take advantage of it? Could a Kruger National Park take advantage of this?
Cities are actually great examples of using Internet of Things. Imagine traffic lights that intuitively influence traffic flow based on high traffic patterns or low traffic patterns. Water and people management, refuse, you name it, across the city, in order to make sure that the city is safer, cleaner, healthier, and just run smarter. In the case of Kruger National Park, poaching is a huge issue. Security is a huge issue. The Internet of Things helps us to bring about predictability, and instead of being reactive to poaching, we could now be far more proactive and prevent animals from actually being lost.
So, what is it? A physical device? What is required for is it connected to a sensor? How does that actually work? Talk to us about the actual end device.
So, the Internet of Things comprises of a solution of stuff, and the stuff has tiny little sensors that may then connect to little computers. Those little computers need connectivity, wirelessly in most cases, to some kind of a back-end system. And the idea is pretty simple. It's to get information, raw information, from a peripheral point, an endpoint, just simply into a database or into some kind of a back-end in order to then provide meaningful information back.
So I think that's the key here, where the sensors or the little devices out there are data collectors.
Right.
Where does the hard work actually happens?
The hard work actually happens in the back end. It's about pulling all of the information together, collating it into something meaningful, and then providing insights that can assist with whatever decision making needs to take place.
And where's Intel's role in all this?
So Intel look at the Internet of Things back to front. We're playing at the smallest of sensors and computing levels, all the way back through the communication into the back end, and having the cloud pull everything together.
We've heard of something called a Galileo board. What is that?
So the Galileo board is a tiny little system on a chip that is able to have sensors connected to it, and send the information back to a back end. What's fantastic about the Galileo board is not just the computing density, but the size at which it operates, the low power footprint at which it operates. So you could easily have Galileo boards powered by solar panels and in very, very remote locations, pulling information which can then be translated into meaningful decision-making processes. From an Intel perspective, what we've noticed is sensors, the Internet of Things, are introducing insurmountable amounts of information, of data. How we correlate and aggregate this information that can, in a way that can then produce meaningful insights is becoming critical to a business. Decision making on the fly is very, very important. Intel has been able to take large amounts of data and process it on commodity hardware, which costs a fraction of proprietary systems, but adds meaningful value to businesses. In the case of Daikin air conditioning, we applied sensors to mechanical pieces of equipment that allowed Daikin to change their business model completely. From selling huge pieces of air conditioning equipment, they could now run cool as a service. What that means is they were able to proactively determine when the equipment would fail and react in many cases before it failed. And what this means for a business is they can buy X number of hours a month of cool versus huge equipment that would then need to go through mechanical and operational cycles. With the car industry, we are finding ourselves applying more and more sensors and computational power to vehicles. This is helping manufacturers understand driving patterns and designing cars that are actually meeting customers' requirements better. What this means practically is that in 2 or 3 years, you would have a car fit for purpose. If you were doing urban runs, you would have a car that had the highest fuel efficiency, was probably a lot smaller in size, and could be easily parked anywhere, that sort of thing. As Intel, working with a jewelry manufacturer, we've designed an amazingly beautiful item of jewelry. It's a bangle that has a tiny little sensor and a touch screen that allows you to read text messages, Twitter feeds, Facebook updates, the odd email, very, very discreetly, very, very visually appealing, and it allows non-geeks to have a taste of wearable computing in a highly fashionable way.